Hello everyone, welcome to our pre-calculus pre-recording video. This is about finding the exact values of trigonometric expressions. This is our lesson 2 video. So let's have a look at the agenda. We will review the trigonometric functions on the unit circle, then common values of trigonometric functions, some tips and tricks, finding the exact values of trigonometric function of pi by 3 or 60 degree. They are same thing, it's in radian, it's in degree. Then some classwork, find the exact value of trig expressions, and then homeworks. So let's have a look. First of all, this one you already have seen. This is from our last class. When we have a unit circle, meaning the radius is 1, and then let's say this is this point coordinate is x comma y, then this will be x and this will be y. Okay, because it is x comma y, we thought about it, we assumed it. Okay, we assumed it. We can say a comma b, then this will be a, this will be b. Okay, something. Actually, in your actual math, this x y will be some numbers. Okay, you will see that in today's lesson actually. So this is x, this is, then the other one is y. Okay, and then we can find out sin theta is actually y and cos theta is actually x from SOHCAHTOA formula. Okay, because this is our adjacent, since the theta is here, so this is the adjacent, and hypotenuse related formula we can use to find out that, and then this one is our opposite and hypotenuse related formula. So that way we can find out. Opposite and hypotenuse related formula is sine, and adjacent and hypotenuse related formula is cosine. That's why we have this. And tan is the ratio of sine and cos. So that way we can think about tan. Okay. This is a unit circle because radius is 1. This is a point. We just have chosen this point. Let's say x comma y. So this will be x and this will be y. Since this is 1, then we can develop this relationship. Now, and this also, these are the 6 trigonometric ratios. These are the common values of trigonometric functions. Okay, it's like sine 0 degree, cosine, this is sine, let me draw this figure. Sine, this is sine, this is that degree. Sine 0 degree value is 0, sine 30 degree value is half, sine 45 degree value is root 2 by 2. Okay, all of them are in degrees like this. Sine 60 degree value is this, then sine 90 degree value is this, sine 180 degree, etc, etc. These values are this. Like this, tangent 0 degree value is this, tangent 30 degree value is this, etc, etc. Now look, so the tips for, if you want to keep these values in mind to be a pro in maths, sometimes, most of the time, even in exam also, we will give you this chart so that you can take this as a help for your calculation. But if you want to not waste your time to go back and look at all these formulas, then you can actually keep this in mind, keep these values in mind, and these values will frequently come in trigonometry. So to be a pro in maths, there are some couple of tips that you can apply for keeping this thing in mind, keeping these values in mind. So what is the tips? First of all, look at the general shape of the values. See, first one is 0. Okay, no problem. Then half, 1 by 2, root 2 by 2, root 3 by 2, 1, 0. Let's take up until here, 90 degree. Then these are something else. So see, 0, half, root 2 by 2, root 3 by 2, and 1. But you see, if you just keep this line in mind, just this line in mind, then actually this line is opposite of this line, coming from opposite order. This is 0 here, this 0 goes just straight down there. This is 0 degree, this is 90 degree. Then this is 1 by 2, this 1 by 2 is actually here. Then this is root 2 by 2, root 2 by 2 is here. This is root 3 by 2, so root 3 by 2 is here. And then 1 is down here, then for cosine 1 goes up for just for 0 degree. So if you just keep this one line in mind, basically you can answer this. Not only this, since this is cosine, you can actually answer the sec also. Since this is sine, you can answer the cosec also, because they are reciprocal. So just by looking at this relationship, actually you can answer all of them. And for tangent, you can just only memorize, just keep this value in mind. Then other values are actually repetition. See, this is 0 here, this is 0 here, and this is 0 here. Corner to corner. All of them are 0. 0, 0, 0. Okay? So corner to corner. In this case, this is 1. This is 1. So corner to corner matching, but unfortunately this is undefined because tan 90 degree is undefined. And there are also reasons for that. I will talk about that in a while. Tan 90 degree is undefined. So 1, 1, but this one is undefined. So that's fine. Now I said that just if you keep this value in mind, then actually you can answer the remaining two questions, because remaining two value, root 3 by 3 and 1 by root 3 is same thing. This is written by rationalizing the denominator, and by rationalizing this one we get this thing. So basically they are the same thing. And see, this root 3 by 3 or 1 by root 3, from this value this 1 and root 3 comes. Just you can think this way for keeping the values in mind. So you will have this, all this value. So just keep this in mind, then you will get this whole line. Then just 1 by root 3. 1 comes first because it is, you can say that this is in the numerator, this is in the upper position, so it comes up, it comes first, then root 3 comes. As I said, I will talk about this. I said this is undefined. The reason is tan is sine divided by cos. Okay, sine divided by cos. So sine 90 degree value is 1 and tan 90 degree value is 0. And anything divided by 0 means undefined. Okay, if you divide any number by 0, it doesn't make sense. That's why it is undefined. Now you can say, sir, by dividing this way, by dividing sine and cosine, we always get this. That's for sure, of course. Even you will not have to keep anything here in mind. Just if you know this one line, from this line you get this. Then from dividing sine divided by cos, then you will get this line. 0 divided by 1 means 0. 1 by 2 divided by root 3 by 2 equals to root 3 by 3. Okay. Root 2 by 2 divided by root 2 by 2. See, same thing. That's why it is 1, because this thing and this thing cancelled out. So basically this one line actually, just if you keep in mind, although it looks a scary figure chart, basically just this one line helps. And what about this thing? This thing is actually from the unit circle. If you think, then from the unit circle it will automatically come. This is a very rough. This value is 1, 0, because it is a unit circle, that's why radius is 1. So this value will be 0, 1, 0, 1, and this value will be minus 1, 0, and this value will be 0, minus 1. And you already know that which one is sine, which one is cosine. So always our first one is cosine, second one is sine. So this is cosine value 180 degree, because this is 180 degree, 0, 90, 180, 270. 0 degree, 90 degree, 180 degree, 270 degree. So suppose sine 270 degree equals to what? This is minus 1, because sine is second value. So sine 270, sine 270 degree is minus 1. That's why it is minus 1, as you can see here. Okay. So this way you can actually keep this whole chart in mind. There is another very interesting way, another tricks to, even without even memorizing this line, you can actually have this line, and that line is very funny. First of all, just write 0, 1, 2, 3, 4. Just 1, 2, 3, 4, as you know, everyone knows that. Then divide all of them by this largest number. Divide all of them by 4. 4, 4, 4, 4, and 4. And then take the square root of all of them. Square root of this, square root of this, square root of this, square root of this, square root of this. Voila, you got the answer. This is 0, which is this value. 1 root of 1 by 4 means 1 by 2, which is this value. Then 1 by 2 by, so this and this cancel out, so this is 1 by root 2, so this is 1 divided by root 2, and as you know, if we rationalize this, then it will become root 2 by 2. Okay, then this is root 4 means 2, and this is root 3, so root 3 by 2, so this is root 3 by 2, and this is 4 cancel out, so basically it is 1. That's why it is 1. So from 1 to 3 4 also you can actually get this all of this common value, these common values. So this tricks also you may find useful. So yeah, even without looking at this again and again, even without memorizing, you can just keep these tricks in mind. That will help to find out these common values of trig functions. Very useful, actually. Very useful. Alright, so trigonometric functions on unit circle. So look at this. Let's look at this thing. You already know the first one is cos theta, second one is sin theta when it is a unit circle. Okay. Just directly they will give us the value when it is unit circle. And tan 60 degree value for sine is root 3 by 2, and for cos is 1 by 2, as you have seen here. Why 60 degree? Actually, we will try to prove from where this value comes. How this value comes more logically, more geometrically, we will try to prove. At least one of them we should prove, then you will think that you can just infer that, or you can just that should imply that other things also can come from this kind of operation. So see, 60 degree, sine 60 degree is root 3 by 2, and cosine 60 degree is half. Similarly, there are some other values also. So this one here, sine 60 degree is root 3 by 2, and cosine is this. And how it comes? Let's try to prove one of them. Okay. 60 and 30 proving is similar. 45 degree is more simple. That's why I have chosen this 60 degree, because if you know 60 degree how to prove, then you will actually automatically know 30 degree how to prove, and 45 degree is actually easier than both of them. Anyway, just this will not be needed for your any exam, by the way. Just proving is we are just showing you so that this gives you some confidence. Okay, like this actually comes from geometry. That's why, or geometrically we can prove them. This way also we can say. So first idea is this is a unit circle. It has to be true first of all, because we have to take it from a unit circle, and we are considering everything from the unit circle approach. So this one is 1. That's why this one is 1. Now suppose we do not know all these things. We just know what? We just know that this is 1, and we are trying to find out it is 60 degree. We just know these two information, nothing else, because this value should come from our calculation. We just know that this is 60 degree and this is 1, because we are trying to establish it for 60 degree, and we know that this is 1. These two information only we know. So this is 1, this is 60 degree, and 90 degree, of course. This one is 90 degree because it is a perpendicular here. Perpendicular. Now see, how can we extend this idea? First of all, when we know that this is 60 degree, since this is 90, automatically we know that this must be 30, because 60 and 30 makes 90. Then 90 plus 90 total is 180. This way. Now, can we draw another triangle here having the same 90 degree angle, same 30 degree angle here? 90 degree will be inside, same 30 degree angle. Can we draw a triangle here? Suppose same 30 degree here, and then just join it here like this. This one actually. Okay, so this is also 30. Okay, 30. So this figure, as you can see. So let's talk about this figure. They're same figure. What we have done here is just only we extended this side of the triangle. Basically, we just multiplied, copy paste. This side and this side is copy paste. Same thing. So what happened here? This is 30 degree and this is 30 degree. Total is how much? Total is 60 degree. So basically this is 60 degree. And this one we already know this one is 60 degree. So 60, 60, 120. Then we need just only 60 degree to make it 180 degree, because in a triangle all angles should add up to 180 degree. So this one 60, this one 60, and this one 60. Now how it helps? See, it helps to develop this idea that since this is same angle, all of them are same angle, and we know that this side is 1, then all of them should be 1. This side, this whole thing should be 1, this should be 1, and this should be 1. Why? Because inside their angle is same, so their side length must be same. Do you understand? It is 30, suppose if it is 30, 30, 30, same, suppose it's not possible. Suppose it is like that, then their corresponding side should be same. In this case it is 60, 60, 60. So to make a triangle, basically, that's why I said that that's not possible. Then it will make just something else. Anyway, so 60, 60, 60, same angle, so their corresponding sides should be same. 1, 1, 1. Now this whole side is 1. That means from here, see, since this is the perpendicular, that means it divides this both of them into 2 equal half. So this must be half and this must be half. This one must be half and this one must be half. So this is half, we know, and this is 1, we know from this figure. That's why we have drawn this figure, to understand that this value is actually half. Okay, so we know that this one. But we do not know this. What about this one? We have no idea. But for that, we have our very helpful friend Pythagoras, or very helpful friend Pythagorean theorem. So that theorem actually can help us. How? Pythagorean theorem says that hypotenuse is square equals to, which is this side is square, hypotenuse is square equals to sum of other two sides square. So let's write the number, okay? Let's write the number. So hypotenuse is 1. That means 1 square equals to sum of other two sides square. That means one side is half square. Another side, this another side here, we do not know. So this is, in this case, it is b. So let's write b squared. Then let's make b as subject. We can keep b in that side also. That's no problem. So this is 1. But this is 1 by 2 whole square. That means basically this is 1 by 4. And if we send it to the other side, then it becomes minus 1 by 4. Here just simplifying it. So this is 1 by 2 whole square. That means 1 by 4. Okay, 1 by 4. And then if we do the LCM here, this will become 4 into 1. That means 4. 4 minus 1 means 3. So it will become 3 by 4 equals to b squared. So b, then b equal to what? Then b equals to will be plus minus square root of 3 by 4. I think now you can see something is coming. So we can write here root 3. We do not know what is the value. We know that, but that's a decimal, so let's keep it as it is. And root 4 means 2. So basically you get root 3 by 2. Root 3 by 2. Root 3 by 2. So you get root 3 by 2 here. And in the book here, they just have taken the positive value. So negative value is not taken here. The reason is, if you think about this thing in our quadrant, this is actually the first quadrant, And in the first quadrant, both x and y values are positive. That's why only the positive values are taken. But actually, we will have negative value in other boxes. Okay. So this negative value is also valid. This is also true. Okay. This is also valid value. Since only we are looking at our first quadrant, that's why we just have taken the positive value. In our another class, next class, we will actually extend this idea to find out, to make it develop more systematically, so that we get all other values in all other quadrants. But let's just look at this thing as we started. So we already know that this one is half, this one is half, this half, this half, this half is here. So we know that this is the half, and we know that this is actually root 3 by 2. For the first quadrant, this is plus root 3 by 2. That's why it is written root 3 by 2 here. So this is 1 by 2, this is root 3 by 2, and this is 1. Okay? And this is 60 degree. Now we know that, so sine 60 degree equals to what? We can just find it out now. Sine 60 degree is opposite divided by hypotenuse, and opposite is root 3 by 2 divided by hypotenuse is 1. That's why sine 60 degree is root 3 by 2 basically. Or we can just simply look at, okay, the distance from here to here is half, and the distance from here to here is root 3 by 2, and we already established that this first one is cosine and this second one is sine. So we already established this. So basically we can say that cosine 60 degree is half, sine 60 degree is root 3 by 2, and then what will be the tan 60 degree? Tan 60 degree is basically, let me mute it. So tan 60 degree is basically the, as you know, sine divided by cosine. So sine is root 3 by 2 divided by cosine is 1 by 2. So this divided by this, whatever it comes, that is the answer of sine 60 degree. Let's find it out. So root 3 by 2 divided by 1 by 2. So then it becomes root 3 by 2 into 2 goes up, 1 comes down, this and this cancel out, so only root 3 is the sine 60 degree value. So basically, when you have sine, cos, and tan, you can actually find out cosec, sec, and cot 60, 60, 60 for this quadrant. So you see, only we started with the idea that this is a unit circle, so this must be 1, and the idea that we are trying to find out 60 degree value here. Then other things actually came geometrically by using the Pythagorean theorem, by using the idea that sum of all angles inside the triangle is 180 degree. This kind of very basic idea. We joined all of them, and then we actually obtained all the values of all six trigonometric ratio values of 60 degree of this angle. Okay, sine, cosine, cosec, sec, tan, cot, all of this. Similarly, actually, we can prove other angles also. Suppose if it is not 60, if it is 45, if it is 30, this kind of thing also easily we can prove. In the book also, actually, they have shown all these little calculations. Okay, so this is a proof for you all. This is to build your confidence. Okay. So yeah, sine pi by 3 means 60 degree. Pi means 180, divided by 3 means 60. 180 divided by 3 means 60 degree. Okay, so already you know now sine 60, cos 60, and tan 60 equals to what? This is called trigonometric expressions, trig expressions. So try to find out the answer of this question. Let me do 1-2 maths from here. So suppose 32 number, if we try sine 30 degree. Sine 30 degree value is what? Sine 30 degree value is 1 divided by 2 minus cosine 45 degree means 1 by root 2 or root 2 by 2. Root 2 by 2. So if we do some LCM here, then it becomes 2 will come here. So 2 is the LCM, then it becomes 1 minus root 2. So this should be our final answer. Okay. When you have something like this 41 number 2 and pi by 3, so you can just first of all convert it to sine pi. This is given in radians, so pi means, already you know that pi means 180 degree. Pi radian and 180 degree is same thing, so this is 180 degree. So we can actually directly just convert it and write it down here. So this is sine basically 60 degree. Then minus 3, this is 10, 180 divided by 6, so basically 10 it is 30 degree, 10 30 degree. Then we just put the value, so this means root 3 by 2, and this means minus 3, 10 30, 10 30 means 1 by root 3 or root 3 by 3, 1 by root 3 or root 3 by 3, both is fine. Root 3 by 3. So this and this cancel out, this and this cancel out, and interestingly, root 3 minus root 3 goes to 0. They gives us 0. So this answer is 0 here. So first of all, if we see this kind of something, then we just can convert it to our regular degree measurement. From the degree measurement, we can actually go for some other additional calculations. Okay. This is how we can find out the exact values of, oh, by the way, why it is called exact value? This is important to understand this. Why it is called exact value? The reason is, do not try to simplify it any longer. It is 1 minus root 2 divided by 2. So just keep it as it is. Because if you try to simplify it a little bit more by writing 1 minus root 2 means 1.41 approximately, divided by 2, etc., etc., and then if you do another line equals to this divided in the calculator, if you do it, then it will be wrong, because the question asked you to find out the exact value, not approximated value. This value is already approximated. We approximated this one. Calculator will give you more and more digits after 1.41. Not only that, if you have just your calculator will give you, let's say your calculator can show 12 digits, but if you look for some better calculator, then that better calculator will give you 40 digits or 45 digits after the decimal. And then if we go for some more sophisticated calculating machine, they will give us hundreds and thousands of decimal values for the root 2. So basically, no matter how many digits after the decimal we take, we are actually approximating something, because after some point we stop. At some point we stop, then after that point all the values we ignore. Okay, so that's why we should not ignore anything. We just we will write in the exact form. We will keep the value intact. We will not make it decimal. We will not approximate anything. That's why it is called find the exact value. Exact value means keep the root and don't do any kinds of approximation in your calculation. Why it is important? The reason is, actually, as you know, this whole thing is just a preparation for bigger and bigger maths solving skills. Now you see, if you have a math related to multiple steps and multiple parts in a math, then say for example this answer you have to take and put it in some other, just suppose put it in some other steps, then you have to follow that new calculation goes in some other steps, and then calculation continues. Now see what happens. If you approximate it, since already you know you have or we have ignored some of the values here, so that ignored values will start contributing in this calculation, and then it will start bending the answer little bit and little bit. This small decimal thing or ignored digit of this decimal thing will start influencing this part answers, and then this part answers, and then at the end it will make a huge contribution to the answer. From the actual answer it will deviate at least a little bit, which mathematicians goal is not, because mathematicians also always wants to get as accurate answer as possible. Okay, sometimes there are limitations, but we will always have to try to find out as accurate as possible in our answer. Okay, So that's why approximation is no good. As much as possible, we will always try to keep the exact values. Not only in this maths, in your future maths or in any other maths, as much as possible. If you suppose, just for example, if you see that 1 by 3, this is a decimal number. Okay, if you write this is a fraction, 1 divided by 3, and don't write it in decimal. That's not good. Okay, just keep it as it is. Although it's a good I mean, there are ways to write it in decimal also in intact form, which is called recurring decimal, since this is 1 by 3. So basically this will be 30, so 10, 0.333333. So this will be repeating. Suppose 22 by divided by 7. This is also an example, and this is also, I mean, if you want to keep it intact, just keep it as it is. Just that's the suggestion here. Exact value means do not write in decimal value, because if we write it in decimal, write something in decimal value, most probably in many cases we are truncating something, we are ignoring some values. But if you are sure, suppose, let me give you an exception. Suppose if you are already sure that this is 0.5, which is equals to half. So half and 0.5 is same thing. So in this case, no problem. Okay, this is also exact. And this one and this one, there is no slightest variation. There is no slightest variation. So this is fine. So if you are sure about something, then it's valid. Okay. Or else always keep it in fraction. Always keep it in root form. Do not break it down anymore. This is called exact value. Exact value means keep it in rational form and keep all the roots intact. Do not write their decimal value. Okay, important. This is also important thing. And for calculating this, for doing this maths, you can use our table from the given table. This one you can use the table, or you can just try to keep it in mind, keep these values in mind, because it will help during the exams and other things. Since if you take maths in your UG level, pre-calculus or calculus 1, calculus 2, physics, statistics and other things, anywhere trigonometry comes, they will actually start involving with this kind of thing. So basically you will be using it for multiple times. So that's why it is better to some degree keep that in mind. Again, if you don't want to memorize it, then you can follow the tips and tricks that is mentioned in this video for finding it out, because it will not also take too much time to find it out, to figure it out. Anyway, so try to solve these maths for practice, and then some other maths from here. And that's all actually for today. Thank you all. Thank you very much. This PDF means the PDF that you have in our Google Classroom. Okay, so there's the PDF page means. Also, our answer, our actual book also have some different page numbers. So page number is a little bit different. PDF means the book that we have given in the Google Classroom, or simply the book that you have. Sometimes we will not mention this PDF, then that will automatically mean that this is the book that you have with you. Anyway, so that's all for today. For reading, focus on unit, circle, unit, exact values, etc., etc. Just for reading. Always it is good to read the chapter. I know it is a little bit tiring, a little bit boring, or a little bit annoying to read on a screen, or even not even in the book also. But always it is good idea to read. Okay, always read the book. This book is so good. This Sullivan book is really good, really good. It is self-explanatory. All right, so always always have this habit of reading. Yeah, so thank you all. Thank you very much. Have a wonderful time, and see you all in the class. Bye everyone.